Hi, and welcome back to a video series on MAT 1033 Intermediate Algebra. My name's Sean Perry. This is video number 48 in the series, General Polynomial Division. So before we dive into the division of polynomials, let's review two topics from the division of numbers, remainders and long division. When we divide a whole number by one of its factors, we get another whole number. For example, if a is equal to b times c, and we divide a by b, we wind up with just the whole number c. Now, since this could be rewritten with a little plus 0 going on here, we would also be able to say b goes into a c times with no remainder. There's nothing left over when I take c groups of b and multiply them together. I actually just get a. I don't need to add anything to that to get to a. However, if b is not a factor of a, then if I divide by b, there'll be a little bit left over, what we call the remainder. And this will be a number less than b. It has to be less than b because if it was more than b, we could fit a whole other group of b in there, and we would just increase our quotient by 1. So the remainder will always be less than the divisor. If it's not less than the divisor, you can keep going with your division algorithm. So let's do a quick numerical example. Let's say I was doing 13 divided by 4. Now 4 goes into 13 3 times to give me 12, and then there's a remainder of 1 left over. So we could write 13 this way, 3 times 4 plus 1. Just as a quick visualization, if I'm making groups of size 4, then I'll wind up with 3 groups of 4 completely, and then when I go to make this next group, I don't have enough. I have one single one left over, and that gives me 13 total. Now notice if that we can write something this way, a equals bc plus r, then if I divide both sides by the divisor b, we wind up with a over b is equal to c plus r over b, once all our cancellations are done. This is just called the mixed number, usually, when you're writing fractions. For example, 13 over 4, 13 divided by 4, is 3 and a fourth. We have a remainder of 1, and we usually write that without the plus sign. But this little invisible space here, this means 3 and a fourth, 3 plus 4. I think that merits some critical notes. Copy this down. Here is the meaning, or the 3 equivalent statements of division by a whole number. If I have a equal to b times c plus r, where r is less than b, a positive number, I should say, less than b, a non-negative number, less than b, then we can say that a divided by b is c, remainder r. Or we could say that a over b is c plus r over b. Notice that b and also c are factors of a if and only if the remainder is equal to 0. 0 being a remainder means that b is a factor of a. Let's refresh ourselves on some terminology here. As we've used them currently, a is called the dividend, the thing which is divided. B is called the divisor, the thing doing the dividing. C is the quotient, the result we get, and R is the remainder, the amount left over. Now we can carry these definitions and these patterns almost word for word over to the polynomials. If we can write a polynomial a as a equals b times c, where b and c are polynomials, then we say that b and c are factors of the polynomial a. And it's a little bit more interesting if b and c have degree 1 or higher, right? Like you could factor out numbers, of course. That's a valid factorization. But it's interesting when you can factor out more than just a greatest common number from each coefficient. Like 2x plus 2 could quote unquote factor as 2 times x plus 1, and that's fine. But we're going to be looking a lot more at a little bit of a non-trivial case here where this is another polynomial with an x in it, not just a number like 2, which is a polynomial just of degree 0. So copy this down. This is the same statement, but now for polynomials. Notice that instead of a remainder being less in value, we're going to need to substitute that with degree. We'll talk a little bit more about that, but also notice that all of these patterns carried over just the same way that they looked for fractions. If we could write a of x is equal to b of x times c of x plus r of x, where these are all polynomials, then we could also say that a divided by b is this quotient c, remainder r, where now these are polynomials. And if we have a fraction of polynomials, we could say that's some whole polynomial c of x plus r of x over b of x, provided, of course, that the degree of a is greater than or equal to the degree of b. This was probably a little bit more obvious for fractions, right? If we have an improper fraction, we can write it as a mixed number. If we already had a lower number on top than the bottom, there'd be a zero here, right? But with this polynomial division, if a and b are of equal degree, you can still divide one into the other to get some number that goes here. We'll talk about this more with examples in a moment. Now, as we mentioned, the main difference, besides all these parentheses with x's in them, is that the r less than b condition, the remainder being less than the divisor, doesn't really mean value of a number anymore. Indeed, we need it to be smaller, but it's not going to mean smaller in value. It's going to mean smaller in degree, the value of the highest exponent. And also, our divisors are allowed to be numbers. These numbers have degree 0 if they're not 0. And so when we want to say, I want the remainder to be 0, it can't have degree 0 because a number also has degree 0. And we just said we need the remainder to be strictly less than the degree of the divisor. This is why remainders have to have degrees smaller than 0. And you could just either think to yourself, it's smaller than 0, or sometimes some books will name it -1 or -infinity or whatever. It doesn't really matter. What matters is the 0 polynomial is thought of as having degree smaller than 0 because remainders like 2 or 3 are actual proper remainders, but their degree is 0 as a polynomial whose largest exponent is 0. So the 0 polynomial, to be a remainder that is special, to be a remainder that is of lesser degree, has to have a different degree. And so it gets a different degree depending on what book you're looking at. Let's do a few examples, okay? So let's first note by foiling that x plus 2 times x plus 1 plus another 1 would give me this polynomial here. So if I know that already, if I know this factorization already, then I can say that x squared plus 3x plus 3 divided by x plus 2 is going to be x plus 1, the other multiplicative factor here, and the remainder is going to be the thing I have to add to that in order to make this polynomial over here the correct resulting polynomial. We may also say, dividing on both sides here, on both sides of this first green equation, if we divide on both sides by x plus 2, then it will cancel from this term and just give me the polynomial x plus 1, and plus the remainder over x plus 2. And from the existence of a remainder, we can see that x plus 2 is not a factor of x squared plus 3x plus 3. It's actually a factor of x squared plus 3x plus 2, and that's off from x squared plus 3x plus 3 by the remainder of plus 1. All right, let's look at another one. If we expand this polynomial here, we could see that we get x to the 4th plus x to the 3rd plus 2x to the 2nd plus x plus 1. And this is almost but not quite equal to what we have over here on the left-hand side. It's actually off in the x place and the 1's place. If I were to add an x and add a 1, then we would have 2's all the way down in this portion here, and that would give us the polynomial we have. So the remainder is x plus 1. That means that you could write this polynomial divided by x squared plus 1 as x squared plus x plus 1 with a remainder of x plus 1. In this final form, we could look at what it looks like to divide the dividend by this divisor. You get this quotient plus the remainder over the divisor. This is a very common way to write the answer in these kind of polynomial division problems. You'll get a polynomial, sort of playing the role of the big number and a mixed number. And then you have the smaller polynomial, smaller in degree than the divisor anyway, over the original divisor, just like you put it over the original denominator in a mixed number. All right, so let's continue with some practical exercises for the day. This is your praxis. I want you to figure out how to complete this table. We have the product sum form of the division, we have the quotient remainder form of the division, and we have the proper fraction form of the division. Here's an example given. I'd like you to figure out what should go in the remaining blanks. Interpret the polynomial on each row and what that could tell you about the rest of the blanks in the table. Pause the video at this time and see if you can figure that out. All right, let's see how you did. So here's the completed table. So in the first row to work on here, we had a polynomial x squared minus 2x minus 9. That could be factored as this minus 1, however. So what does that mean? Well, you could actually pick either of those two to be your divisor. If you were to divide by x minus 4, you would get x plus 2 as a quotient and a remainder of -1. Likewise, if you were to divide by x plus 2, you would get a remainder of x minus 4 with a remainder of 1. And we have some options about how to set this up too. If you write it over x minus 4, then here's your quotient, here's that remainder. We usually pull the minus sign out front. And likewise, for if you decided that x plus 2 is your factor, you actually had some options for this one. What about this middle one? Here we said, look, if I divide this cubic by this quadratic, I get x plus 1 with a remainder of 1. So we could either write that as a product of the divisor and the quotient plus the remainder to get me the dividend, or we could take the dividend over the divisor equal to the quotient plus the remainder over the divisor. Like this is missing a 1. Okay, and then what about the last one? Here we have a numerator and denominator, and over here I don't seem to see any plus fractions going on. What's going on over here? Well, this is just the quotient. This has no remainder. This is plus 0 remainder. And so we could write this as a quotient. Dividend divided by divisor is equal to quotient remainder 0. In other words, these two, x plus 6 and x plus 1, are factors of the polynomial x squared plus 7x plus 1. Okay, that's it for this video. Thank you very much for your patience and have a great day. Good luck with your studies. I'll see you in the next one.